Hey guys, so I know a lot of you were absent on Friday, so I wanted to go ahead and just give you a brief rundown of what we talked about on Friday. So we got into our unit on the unit circle. So our main idea from Friday was just learning how to build the unit circle. And the reason we want to know this is because the unit circle allows us to evaluate trig functions, like the value of sine or cosine for a specific angle measure, without having to use our calculator. Now we'll talk more about exactly which trig functions match up with which, but like I said, we're just going to talk today about how to build the unit circle. So we have a circle, obviously. Now in class we used paper plates to build these, so if you have a paper plate, go for it. If not, you can use a piece of paper and cut a circle out. That'll work the exact same way. Alright, so let's get started. So the very first thing we're going to need on our unit circle is our axis, so like our coordinate plane. So to make those, you'll need a vertical and horizontal line. So go ahead and fold your paper plate in half and make a crease. Then unfold it and fold it the other way and again make a crease. Now I'll use several different colors for this, so I'm going to use black as my coordinate plane. So I'm going to trace those lines that I just made. Okay, so this is like my X and Y axis. Now, since we have a circle, each one of these is a degree measure. So from this line to this line, if I draw an angle, this should be a 90-degree angle. So we're going to label this as 90 degrees. Now if I go from this line all the way around, here we have 180 degrees. So we'll label this one as 180 degrees. Again, coming back around, that means that from here all the way around to here is 270 degrees. And coming full circle, this would be 360 degrees. Or, as we got started, this could also be a 0-degree mark. Okay, so we've got that labeled. The next thing is coordinate pairs, because this is an X and Y axis, so that means that each point here has a coordinate pair. Now this is called the unit circle because the length of a radius, so anywhere from the center to the end of a circle, is 1 unit. So if I go from my origin and I go over 1 and up 0, that means that this coordinate pair is 1, 0. So let's label that. Using that same idea, that means that from my origin up, this point has a point of 0, 1. From the origin to the opposite side, here I now have -1, 0, and at the bottom we will have 0, -1. So now we have coordinate pairs for each part of our axis. But I can divide a 90-degree angle again. I can divide it in half, and let's do that by folding our plate diagonally. So if I line up the 0 degrees with the 90 degrees and fold and make a crease on my diagonal, I can unfold it and do the exact same thing the other way. Now let's line up the 90 and the 180 and the 90 and fold a diagonal the other way. Now I'm going to use a different color and trace these lines. Okay, so the black lines are my coordinate plane. The yellow lines are the new creases that I've made. So what angle measure is this? If I go from 0 halfway to 90, this is now a 45-degree angle. So let's label that. 45 degrees. I've made another, so then it's another 45 degrees to 90. Another 45 degrees puts me now at 135. So let's label that one. Another 45 degrees puts me at 180. Another 45, I'm now at 225. 45 puts me at 270. Adding 45 again, I'm now at 315. And then adding my final 45 degrees puts me back at 360. So I've now made it all the way around my circle. Now the question is, again, so we talked about how the unit circle, each one of the radius is a unit. So here is 1 unit in length. But what is this coordinate pair? Because if this is a coordinate pair, that means this point here is also a coordinate pair. Well, the question is, how do we find that? Well, let's see what that distance is. So for this point here, I can drop down that line. So that means some distance x and some distance y gets me to this point. Well, notice that I've made a triangle. What kind of a triangle? This is a 45, 45, 90 degree triangle, which is awesome because in geometry you learned about special triangles. So we'll see within this unit circle is a couple special triangles hidden. And that's a good thing because using our rules of special triangles, special right triangles, excuse me, we can find what those degree measures are, what the side lengths are. Now, hopefully you remember this from geometry. If not, Khan Academy has some great videos on how they derive these. But a 45, 45, 90 degree triangle has certain proportions of the side lengths. And those proportions are that because this is a isosceles right triangle, these two legs are congruent to each other. So they have a side length of x. Well, Pythagorean theorem says that a squared plus b squared should equal c squared. So that means that the side length of my hypotenuse should be x squared plus x squared equals c squared. So that would be x squared plus x squared equals the square root of 2x. Well, let's say that our side lengths are 1. Let's call the x's 1. So that means that this one has a side length of 1, 1, and the square root of 2. Now we talked about that the unit circle, the hypotenuse, or any radius, which in this case would be the hypotenuse of our triangle, has a side length of 1. So I don't want my hypotenuse to be square root of 2, I want it to be 1. Well, the only way to do that is to form a similar triangle by dividing each of our legs and hypotenuse by the square root of 2. So square root of 2 over 2 is 1. Now 1 over the square root of 2. We cannot leave it like this. We have to rationalize the denominator, which, like we talked about in our radicals unit, I can multiply the top and bottom by the square root of 2, get rid of the radical. So this is now square root of 2 over 2, and this one becomes square root of 2 over 2. So these are the coordinates for our other triangle. So if we come back to our unit circle, here, this leg is a length of square root of 2 over 2. This leg, our height, has a length of square root of 2 over 2. So that means that this coordinate pair here should be square root of 2 over 2, square root of 2 over 2. So this is our first coordinate pair that we found. Now, I've attached a file with these triangles in the materials tab for the unit circle. But if we use a triangle, so if we line it up, we'll notice that we have our length and our width with a length of square root of 2 over 2 and square root of 2 over 2. Watch what happens as I reflect this triangle first over the y-axis, then over the x-axis, and again, and once more. If I know my first quadrant, I can find all the other points around my triangle or around my circle simply by doing reflections. So knowing this, if I flip this triangle over, now we said that this triangle has, now obviously mine aren't perfect because my folds were not perfect on the paper, but this triangle has a length of square root of 2 over 2, square root of 2 over 2. But I'm now going in the negative direction. So this coordinate pair isn't the square root of 2 over 2, square root of 2 over 2. It's actually going to be negative square root of 2 over 2 and positive square root of 2 over 2. Anything in our third quadrant is negative and negative. So this coordinate pair is negative square root of 2 over 2, negative square root of 2 over 2. And finally, in the fourth quadrant, we have positive and negative. So positive square root of 2 over 2, negative square root of 2 over 2 is the coordinate pair for this one. And that's how we find the first set of our pairs. But there's one more special triangle that we talked about in geometry, and that was a 30, 60, 90 triangle. So in our 30, 60, 90 degree triangle, these ratios are the hypotenuse has a length of 2x, one leg is x times the square root of 3, and our final leg is just x. So if we consider all of our x's to be 1, again, we don't want this hypotenuse to be 2. We want it to be 1 because any radius, or in this case hypotenuse, should have a length of 1. So I need to divide all my side lengths by 2. And now we'll find that when we make a 30-degree angle, our length should be radius of 1, one leg of square root of 3 over 2, and our final leg of 1/2. Now you can use a protractor to measure your 30-degree angle, or I posted the triangles below so you can use those triangles and measure your 30-degree angle. So if you've printed them off, take your 30-degree angle, line it up with your axis, and we can trace along the hypotenuse. So this line here, again, it's not perfect, but this line here is a 30-degree angle, which means this here is our 30 degrees. I can find the next point by reflecting it over the axis. Now this one you can think of as either 180 degrees minus 30, so 150, or starting from our initial line, this angle going all the way around is 150 degrees. So here we have a measure of 150 degrees. Again, I can reflect it over the axis again and get our next angle measure of now 180 plus 30. So this would be 210 degrees. And then reflecting our again, I can get an angle measure of 360 minus 30 or 330 degrees. So now that we've got the angle measures, we again want to find what these coordinate pairs are. So just like we did on the first one, I can drop down this section and form our 30, 60, 90 degree angle. Now what did we say those side lengths were? That the bottom leg is square root of 3 over 2, and our height is 1/2. So going over, this is a length of square root of 3 over 2, with a height now of 1/2 instead of square root of 2 over 2. So this one has a coordinate pair of square root of 3 over 2 and 1/2. This point has a coordinate pair of negative square root of 3 over 2 and 1/2. Negative square root of 3 over 2, negative 1/2. Square root of 3 over 2, negative 1/2. So that's almost all of our points for our unit circle. Now there's only two special triangles, special right triangles. We have the 30, 60, 90 and the 45, 45, 90 degree triangle. But can I flip my 30 and 60 degree angle and still have a special triangle? Certainly. If I flip those angle measures and now make the angle measure that I'm going to use 60 degrees, now all we do is change our points around. Our hypotenuse still stays 2x. One of our legs is still x times the square root of 3, and our final leg is still x. This is just going to change the height and the length, or our x and y coordinates, for the final triangle. Now, again, you can use a protractor and measure a 60-degree angle, or if you printed off those triangles, your third triangle is that 60-degree angle. So we can line this one up and trace our 60-degree angle. So this one here would be 60 degrees. And then finally, using reflections, I can get the other angles. So keeping our 60-degree angle at the origin, here's our next 60-degree angle. Reflecting it again, we get our third, and with one final reflection, we get the fourth. So we have 60 degrees, adding another 60, that makes this angle 120 degrees. Adding 60 gets us at 180. Adding our 60-degree angle gives us 240 degrees. Our final angle then is going to be 360 minus 60, or 300 degrees. Now the next thing would be those the coordinate pairs. Now finally, again, drop down your height, because this coordinate pair is found by going over some distance and up a distance. And like we just talked about, that would make the length, the base of it, x, which we figured out over here is 1/2. So now, instead of our length being square root of 3 over 2, it's going to be 1/2, and our height is going to be square root of 3 over 2. So this coordinate pair is 1/2 square root of 3 over 2. This coordinate pair is going to be negative 1/2 square root of 3 over 2. This coordinate pair is negative and negative, so negative 1/2, negative square root of 3 over 2. And our final coordinate pair is 1/2 square root of 3 over 2, negative, excuse me. And now we've completed our unit circle. So each of these coordinate pairs correspond to a specific angle measure. Now, like I said, we'll talk about on Monday which one of these is exactly what, so which one's cosine and which one's tangent, because each one of these angle measures corresponds to sine, cosine, or tangent. And we can figure them out without using our calculator for these specifics, 30, 45, and 60-degree angles, or even 0 and 90. We'll talk about that some more on Monday. But what I wanted you guys to do over the weekend was see if you can try to build the unit circle on your own. Because being able to quickly recognize these numbers and have them easily at the forefront of your brain will make what we do for the rest of the unit much, much easier. So if you can, take a second and try to build this on your own, and we'll talk about it some more on Monday. See you guys then.